Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is algebraic graph. Lesson 6, Quadratic Equations Graph, Part 3. Example 5, Roman figure I. Copy and complete the following table for the relation y equal to 3 minus 4s minus 2s squared. You can see the table of values with some missing values for y. Roman figure 2, draw the graph of y equal to 3 minus 4s minus 2s squared for the values of s ranges from minus 4 to 2. That is minus 4 less than equal to s less than equal to 2. Taking 2 centimeters to 1 unit on the s axis and 1 centimeter to 1 unit on the y axis. Roman figure 3. Using the same axis, draw the graph of y equal to 3s plus 4. This is a linear equation. So here we are plotting a quadratic and a linear equation on the same graph note. Roman figure 4. From the graph, find the values of s correct to 1 decimal place for which a part of Roman figure 4, 3 minus 4s minus 2s squared equal to 0. B part of Roman figure 4, 3 minus 4s minus 2s squared equal to 3s plus 4. Roman figure 5, state the maximum value of y and the corresponding value of s. That is, the value of s at the maximum value of y. So this is the whole problem. So we start by completing the table of values before we do any other thing. So the next thing is to get the complete table of values for the quadratic equation and the linear equation. So table of values for y equal to 3 minus 4s minus 2s squared for the range of values of s minus 4 to plus 2. For us to get y outside the constant 3, we need to get minus 4s and minus 2s squared. When you add everything together, you get y values. So let's start with the s values. They are already given to you in the table from minus 4 to 2. The next term in the equation is 3. 3 is a constant, so you write 3 under each value of s. Next, we must get minus 4s. You multiply each value of s by minus 4. So minus 4 times minus 4, you have 16 minus 3 times minus 4 equal to 12 minus 2 times minus 4 equal to 8 minus 1 times minus 4 is equal to 4. 0 times minus 4, you have 0. 1 times minus 4, you have minus 4. 2 times minus 4, you have minus 8. For us to get minus 2s squared, let us first get s squared. To get s squared, you square each value of s. Minus 4 squared equal to 16, minus 3 squared is equal to 9, minus 2 squared is equal to 4, minus 1 squared is equal to 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So you multiply each value of s squared by minus 2. Here become minus 32, minus 18, minus 8. That is 4 times minus 2 now, minus 8. Then minus 2 times 1, minus 2. 0 times minus 2, 0. Minus 2 times 1, minus 2. Minus 2 times 4, you have minus 8. So to get y value, we need this and this and this. The row in green, that is what you add. So 3 plus 16 minus 32, you have minus 13. Then 3 plus 12 minus 18, you have minus 3. 3 plus 8 minus 8, you have 3, and so on. The last value, you have 3 minus 8 minus 8, that is minus 13. Let's jump to Roman figure 3 and get the table of value for the linear equation y equal to 3s plus 4. We are to use the same values of s, that is minus 4 to 2. So we get 3s. To get 3s, multiply each value of s by 3. So 3 times minus 4, you have minus 12. 3 times minus 3, you have minus 9, and so on. The last value, 3 times 2, you have 6. Plus 4 is a constant, so you write it under each value of s. To get y value, you add the values in the green row. That is minus 12 plus 4 is minus 8. Minus 9 plus 4 is minus 5. Minus 6 plus 4 is minus 2, and so on. The last value, you have 6 plus 4 equal to 10. So we have gotten the tables of values for the two equations. So let's take Roman figure 2, where we have to plot the quadratic graph. Let's start with the scale. 2 centimeters equal to 1 unit on the x-axis, 1 centimeter to 1 unit on the y-axis. So you can see the graph. The s as the scale means that you combine 2 squares or 2 boxes and give it 1. The next 2 is 2. The next 2 becomes 3, and so on. If you move to the left, you do the same thing but in negative form. This scale for y, what we have there is 246. It is the same as 1 cm to 1 unit. In order not to have too many values on the graph, so I skipped 1, 3, 5, 7 like that. So here is 1. This is 1 centimeter equal to 1 unit. The next centimeter becomes 2. The next one is 3. You have 4, and so on. If you share very well the values of s and y, especially y values, we have the negative value there is up to minus 13. So when you want to draw the x-axis, you have to give more space to the negative y value. for when you are drawing your x-axis, you have to look at the y values. With the nature of negative and positive values, you know where to draw your x-axis. In this problem, if you draw it equal as in the previous lesson, that is lesson 5, you will not be able to accommodate minus 13. So you draw it so that you give more space to the negative value. For y value, if you look at it, if the values can be accommodated, you can draw it at the middle. If all the values can be accommodated, if not, you have to give more space to the side with more values, either negative or positive. Always consider this when you are drawing your axis. So this K also means that one line represents 0.1 units on the x-axis and 0.2 units on the y-axis. Okay? Let's look at the table of values for the quadratic equation. The first point, when s is minus 4, y is 13. That is minus 13. After minus 12, you have minus 13, and this is minus 4. The point of contact is here. You mark that point. The next point, when s is minus 3, y is minus 3. This is minus 3 for y by the scale we have now, and this minus 3 for s. This is the point of contact. When s is minus 2, y is 3. We are going up now. So when y, this is okay, when s is minus 2, y is 3. So this is the point for y equal to 3, and s is minus 2. So you asterisk that point. When s is 0, y is okay. The first point, okay, when s is minus 2, y is 3. That is correct. When s is minus 1, y is 5. So this is 5 and s is minus 1. This is the point of contact. You asterisk it. When s is 0, y is 3. Okay, so when s is 0 here, y is 3 now. That's the point you have here. You plot this point directly on the y-axis. When s is 1, y is minus 3. You are going down again. The graph is now descending. When s is 1, y is 3. That is this point. And when s is 2, y is minus 13. That is this point. Now that you've plotted all the points, next thing is to join them together. Don't forget, the title of the graph is the equation or equations that you are plotting. Hello. So all the points have been joined together. We move to Roman figure 3, and in that problem we are to construct a linear graph on the same graph sheet with the quadratic one. So already we've done the table of values before, so we bring it in. And the first point there, when s is minus 4, y is minus 8. So this is minus 8 for y and minus 4 for s. This is the point of intersection. The next point, minus 3 for s, minus 5 for y. This is minus 5 for y. This is minus 3 for s. You have the meeting point here. The next point, minus 2 minus 2. So this is minus 2 for y, minus 2 for s. This is the meeting point. The next one is minus 1 for s plus 1 for y. This is plus 1 for y, minus 1 for s. This is the meeting point. And the last point there is 2. Okay, we've jumped. We're supposed to have 0 first. When s is 0, y is 4. S is 0, y is 4. When s is 0 here, y is 4. You plot it directly on the y-axis. The next point, when s is 1, y is 7. So you have s is 1, then y is 7 somewhere here. And you have when s is 2, y is 10. You can plot it there. Already the points we have now are enough. Alright. So you've plotted all the points for the linear graph. Next is to join the points together and use the resulting graph to solve the given equations. So you can see that the points for the linear equation have been joined together. So this is the whole graph that we are asked to plot. So we move to Roman figure 4. From the graph, find the values of s correct to one decimal place for which 3 minus 4s minus 2s squared equal to 0. This equation is for the curve only, for the curve. What this means is that find the solution when y is equal to 0. From the given equation, everything here is equal to y. So if you replace this with y, it means y is equal to 0 is the solution. And this is 0. What it means is that the points where the curve cuts across the s-axis. As simple as that. So you have to locate that point. One point is here, another point is here. Okay, so this is 2.5. After 2.5, you just have one line away. That means you have minus 2.6 is the first root. When you come here, you know this place is 0.5, and you also have one line. That means you have 0.6. The solution to that equation is minus 2.6 or 0.6. Roman figure, okay, that is part B of Roman figure 4. We are to find the solution to 3 minus 4s minus 2s squared equal to 3s plus 4. The left hand side is the curve and the right hand side is the linear equation. So the point of intersection of the curve and the line gives the solution. This is one point of intersection of the curve and the line. This is another point of intersection of the curve and the line. So you mark that point accurately and you trace it to the s-axis. When you trace the first one, you have minus 3.4. If you trace the second one down, you have minus 0.2. You must do that accurately. Now figure 5, we should find the maximum value of y equal to 3 minus 4s minus 2s squared. Remember, in the introduction I told us that the n-shaped parabola always produce maximum value, and the u-shaped parabola, as in lesson 5, always produce minimum value. We have n-shaped parabola, so we have the maximum value is the peak of the curve, and that is this point. So you trace that point to y-axis and you trace it to s-axis because the question says so. So the maximum value is 5, and the value of s at which it occurs is -1, and that is what you have here. Hello. So this is how you plot the graph and use it to solve some equations. It might not be the one you plotted, but you always simplify the given equation to the one you plotted in order to use the graph to solve that equation. End of lesson 6. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not safe, your life is in crisis. To avoid that, give your life to the one that can save you, and that is the Lord Jesus Christ, and confess him as your Lord and personal Savior. If you are saved already, congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be led. Take good care of yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.